Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. As we have been bringing the series of sessions for KVPY preparation and now it has been discontinued and some other exam or some other system will come in that place. This session is not only for KVPY but it is also for other exams like JEE, Mains, Advanced, ISI, CMI. Today's topic is telescopic sum or VM method, which is one very important topic of progression chapter. Using this method, we can find sum of a sequence whose term can be written as difference of 2. How it is done, I'll tell you, but let me tell you, this method is useful not only for those series which are either in AP or HP or AGP, but also outside this sequence and series chapter, like trigonometric series, inverse trigonometric series, some integration, differentiation, binomial coefficient, many such series you can add using this telescopic sum. So I will first tell you what this telescopic sum is and then I will take few examples to explain that. So let us assume we are given this series Sn, which is the sum of T1, T2, T3 and so on Tn. Now if we are able to write this Tr as V of r plus 1 minus Vr. Okay, so these two Vr plus 1 and Vr, they both are same things, but you can obtain one from the another by changing or interchanging r with r plus 1 or r plus 1 with r. So this is the difference between Vr plus 1 and Vr. Now if you write r is equal to 1, so T1 will be V2 minus V1. If you write r is equal to 2, then T2 will be V3 minus V2 and so on. Tn will be Vn plus 1 minus Vn. Now if you want the sum of all these terms, so you can see here this V2 will get cancelled with this V2 term. This V3 will get cancelled with the next with the term V3 in the next term. Okay, and so on. And similarly this Vn will also be cancelled with one term before it. So what will be left? The only two terms that will be left are Vn plus 1 from the last Tn and V1 from the T1, and this will be the sum of n terms. So this is how this telescopic sum works. In some cases Tr may not be Vr plus 1 minus Vr, rather Vr plus 2 minus Vr. In fact, Vr plus 3 minus Vr is also possible. But in this case, you have to understand the difference. T1 will be V3 minus V1, T2 will be V4 minus V2, and so on. And if you start adding them, you can see the terms will not cancel immediately. Like V3 will be cancelled with this V3 here. Similarly, V4 will be cancelled, V4 here, which will be written in T4 here. Okay, and so on. So you can see these first two terms V1 and V2 will never be cancelled, and same way these two terms will also not be cancelled with any terms before it, though this will be cancelled, this will be cancelled with the terms before it. So Sn in this case will be Vn plus 1 plus Vn plus 2 minus V1 minus V2. So this is also possible that you have to keep track of, or you have to keep record of two terms from the beginning and two terms from the last. So this can also be the sum Sn. Now to start with, let me tell you some typical questions which are done on these this Vn method only, on telescopic method only. So first type of questions are in which you will be given a series in which each term is composed of reciprocal of product of r terms or r factors in AP, and first factor of several terms is also in same AP. Like you can see here 1, 2, 3, 4 is an AP, and if you compare first term with first term of this, they are also in the same AP. Okay, now to do such question, the standard method is first you write Tr, which you can see is equal to 1 upon r into r plus 1 into r plus 2 into r plus 3. Okay, now what we will do, we will multiply by the difference of the extreme factors written in the denominator. So what is the difference of extreme numbers? R plus 3 minus R. And this is nothing but 3. So we will divide by 3 also, so that this TR remains same as it was earlier. But what is the benefit of doing this? I think this will give you TR to be equal to 1 by 3 into 1 upon, this will be R here, R plus 1, R plus 2 minus 1 upon 3 into 1 upon, here it will be R plus 1, R plus 2 into R plus 3. Now you can check. These two terms are such that if you replace R with R plus 1, you will get this. If you replace R plus 1 by R, you will get this. Okay. Now you will be able to see how VN method will work here. If I put R is equal to 1, we will get 1 by 3 into 1 upon 1 into 2 into 3 minus 1 upon 3 into 1 upon 2 into 3 into 4. Then if you put R is equal to 2, T2 will be 1 upon 3 into 1 upon 2 into 3 into 4 minus 1 upon 3 into 1 upon 3 into 4 into 5 and so on. Now if you add them, you can check. The cancellation has started. In this case, this term is getting cancelled. This will get cancelled with this if you add. So this will remain. Similarly, other terms will also get cancelled. In that nth term, I will not do this question completely because it is one very easy question. I will leave this for you. You can write a Tn and you can check one term of Tn will be remaining, one term of T1 will be remaining, and that will give you the sum of n terms of this series. Okay, so this is how type 1 questions or VN method are done. Okay, now there is one more example on that. You can see these two are again forming AP with the difference 2, 2, 2, and if you compare the first terms, they are also doing the same thing. So what is supposed to be done? I think I will be doing same thing. I will take the difference of extreme numbers in the denominators of 5 minus 1 upon 1 into 3 into 5, and for that I have to divide by 4 also. Then 1 by 4 into, here we will do 7 minus 3 upon 3 into 5 into 7 and so on. Okay, and you can check here also, you will be able to cancel the terms. So 1 upon 1 into 3 minus 1 upon 3 into 5 plus 1 upon 4, here it will be 1 upon 3 into 5 minus 1 upon 5 into 7 and so on and so on. I will leave for you to do this question completely, but here you can see this is getting cancelled, and same way this will also get cancelled from the next term and so on. So one term is remaining from the first term and one term will be remaining from the last term. You can write what will be the last term, 1 upon 4. You can write what will it be. I think nth term here would have been 1 upon 2n minus 1, 2n plus 1 and 2n plus 3. So this would have been 1 upon 2n minus 1, 2n plus 1 minus 1 upon 2n plus 1 into 2n plus 3. So here, because this term is remaining, so here I think this term will be remaining. Okay, because this was with plus sign, so one term should remain with minus sign. So final answer will be 1 upon 4 into 1 upon 3 minus 1 upon 2n plus 1 into 2n plus 3. Okay, I have taken examples in which you can see the cancellation immediately after. But there are possibilities, as I told you, if your TR comes out to be like this, then this cancellation may occur after a gap of terms. Okay, I'll just give you an example on that. You can note it down and you can do it yourself. Suppose you are given TR is equal to 1 upon R into R plus 2. Okay, and you have to find Sn. Sn means sigma TR. So in this question, please do it same way. You will be able to feel that difference or cancellation is not occurring immediately after. It will be happening sometimes after. One term later, or maybe 2 term later. Please check this out yourself. Okay. Now coming to type 2, this is also one very important thing you should know. Otherwise, what happens in such questions, we use the formulas like sigma n square, sigma n cube, that will not be needed for at least such questions. Here you will require lots of calculation to be done. Please see, first here there will be a series in which each term is composed of r factors in AP, the first factor of several terms being in the same AP. So the term which you are seeing is same as was there in type 1, except here we are seeing them in the numerator. Earlier it was there in the denominator. Now what is to be done, please see. Here what we will be doing, earlier we multiplied with the difference of extreme numbers, if you remember. Here we are not going to do that. Rather, we will be multiplying by the difference of two numbers, one which would have come if this AP would be continued. Like 1, 2, 3, 4, next number would have been 5. And one number before it would have been 0. So we will be taking the difference of these two numbers, not 1 on 4, but 5 which would have come next and 0 which would have come before. So we will take the difference of 5 and 0. But for that I have to divide by 5. Then next it will be 1 by 5, and here it will be 2 into 3 into 4 into 5, and here I will write 6 minus 1. You can check for this term, next expected term would have been 6 and first or term before 2 would have been 1. So taking the difference of this, and similarly for the next one, 1 upon 5, 3 into 4 into 5 into 6, and here we will be writing 7 minus 2. So what is the advantage of this? Let us see. Advantage will be, you can see this 1, 2, 3, 4, 5 will be cancelled with 1, 2, 3, 4, 5, isn't it? Then 2, 3, 4, 5 into 6 will be cancelled with 2, 3, 4, 5 into 6, and so on. And here if we will write the nth term, I think we will get 1 by 5. Nth term would have been I think n into n plus 1 into n plus 2 into n plus 3. And for that we will be multiplying it by n plus 4, the next expected term, minus the term that would have come before n. Now because here the term with minus sign has remained, so here term with plus sign will remain. This n minus 1 multiplication with n plus 1, n plus 2, n plus 3 will cancel, you can check. So the answer here would be 1 upon 5 into n plus 1 into n plus 2 into n plus 3 into n plus 4. So I think this is much easier than using sigma n square, sigma n cube. In fact, in this particular question, you will require sigma n power 4 also, which is not there in our syllabus directly. But if you are going to do this by this method of sigma n square, sigma n cube, then you have to use this result also, which you will have to derive yourself. So this is how you can do it. Now let me tell you, using this method you can remember some of the results. Please see which results I am talking about. Suppose we have to add those terms in which 1 plus 2 plus 3 and so on is done till n. I think this we all know, it is n into n plus 1 by 2. Okay, but if my series is 1 into 2 plus 2 into 3 plus 3 into 4 and so on, and nth term is n into n plus 1. So using the same method I told you on our previous slide, you can check, it will come out to be 1 by 3 into n plus 1 into n plus 2. You can check. If it starts with 1 into 2, 2 into 3 and so on. And same way 1 into 2 into 3, then 2 into 3 into 4 and so on. And last term n into n plus 1 into n plus 2. This will be 1 upon 4, isn't it? n plus 1, n plus 2, n plus 3. So this is how you can write. You can use these results also in some of the questions. I will tell you the utility of this. So tell me, all of you, can I say that summation of the first one was r, so it is n into n plus 1 by 2. r is starting from 1 to n. If we take r into r plus 1, so this is r is equal to 1 to n, and this comes out to be 1 by 3, and it will be n into n plus 1 into n plus 2, and so on. I will not write all, but please remember these results, they will be very, very useful. And let me tell you the utility of these results in, proofs of these. Although you may be knowing it already, but the proof of these series are not that easy. I think first one is direct, you can write n into n plus 1 by 2. Okay, but second one or third one, if you try to find the sum of these two series, you may use some n plus 1 cube minus n cube and then writing all of them. It looks like it is some very unusual kind of method, that how this will come into my mind. So I'll tell you how you can derive second one or third one. Please see. So if I have to derive second one, and the second one was actually summation r square, in which r is starting from 1 going up to n. So can I write this as, tell me all of you, r square plus r and minus sigma r. I think we can write it like this. So this will become sigma r into r plus 1. Okay, bacho. And here it is r is equal to 1 to n, and here also r is equal to 1 to n. So if you remember 2 slides back what I said, we can write this directly, isn't it? It will be 1 by 3 into n plus 1 into n plus 2, isn't it? And minus, this is n into n plus 1 by 2. So we can take n into n plus 1 into, n into n plus 1 upon 6 as common. Then here we will be getting 2 times n plus 2 and minus 3 here. And I think that is the result, isn't it? How easy you can see. But for that you should understand what I said here. Okay. Now similarly you can do it for r cube also, although it will be little more not complicated, little lengthy, but you can do this also. How you can do it, please see. We can write this as r into r plus 1 into r plus 2. If you want to use that result which I told you, you have to write as r plus 1, r plus 2, product of 2 or 3 or 4 consecutive numbers. That is how you have to write. But here it was only r cube. So what I have done actually, I have to subtract by, how much will it be? I think 3r square plus 2r I have to subtract, isn't it? Okay, so I will further write this as r into r plus 1 into r plus 2. Okay, and minus, I will take 3 common, then it will become r into r plus 1. I have written 3r square as 3 common, r into r plus 1. For that I have to subtract by r here. Okay, subtract by r here, and minus 2 times sigma r. So you can see this will become summation r into r plus 1 into r plus 2 minus 3 times summation r into r plus 1, and here it will be plus 3, so minus and 3 minus 2, so 1, so summation r with plus sign here. And you know all these 3 can be written directly, isn't it? And then if you simplify it, you will get your answer. Easy. So these are the applications. I have just started the application of this telescopic sum, but let me tell you now few questions which are not AP, not GP, HP, AGP, nothing, but some other sequence still we can find using the this VN method or telescopic sum. Please see how. So here you are given the rth term as r upon 1 plus r square plus r power 4. I think you all know how to factorize the denominator. We can write the denominator as 1 plus r square whole square minus r square. I have added r square, so it becomes perfect square. I subtracted r square also. So here it will become r upon, please check, and let me write this as r square plus 1 plus r as first factor, and r square plus 1 minus r as another factor. You can also write the denominator, numerator as the difference of these two, r square plus 1 plus r, these two brackets which were there in the denominator. So r square plus 1 minus r. But for that, I think you are having 2r in the numerator. So I will have to divide by 2 also. And here we are getting r square plus 1 plus r into r square plus 1 minus r. Okay, so if we, and there will be big bracket here also. So you can see this will now become equal to 1 upon 2 into, in that bracket 1 upon, I think first bracket will cancel and we will have r square minus r plus 1 minus 1 upon r square plus r plus 1. Okay, let me write this tr once again here and you will see it is 1 upon 2, and please notice it carefully. Here it is r into r minus 1 plus 1, whereas in the second term it is r plus 1 into r plus 1. Okay, so you can see these two has become VR, you can call this as VR, you can call this as VR plus 1. You can check, replacing r with r plus 1 will give you VR to VR plus 1, and replacing r plus 1 with r will give you VR. Okay, so now it is time to start doing it. T1 will be 1 upon 2 and here you will get 1 upon 1 into 0 plus 1 minus 1 upon 2 into 1 plus 1. T2 will be 1 upon 2, 1 upon 2 into 1 here plus 1 minus 1 upon 3 into 2 plus 1 and so on. And in the end we can write Tn also, and I hope you understand what is now left. Now nothing left, I think we just have to write the answer. N into n minus 1 plus 1 and minus 1 upon n plus 1 into n plus 1. So if you add them, we will get this term cancelled with this cancelled with the next, and because this term with plus sign is remained, so this will be cancelled. Okay, this will remain. So the Sn would be 1 upon 2. I think here we are getting 1 upon 2 here. 1 upon, not 1 upon 2, it is 1 only. 1 into 0 is 0, 0 plus 1, so 1, and minus 1 upon, we will get, I think this, yeah, this is correct. This will be n plus 1 into n plus 1. There will be bracket here also. I hope you understand this. So this is the answer for sum of n terms. Now if we want sum of infinite terms, we can use this result itself. I think let me use this space here. When n will become infinity, I think 1 upon n plus 1, n plus 1 will become 0, isn't it? Because as number n becomes large, this term will become approaching to 0. So here that s infinity will be nothing but 1 by 2, that's it. So very easy, you just have to figure out how to write this as VR, difference of VR and VR plus 1, and then we are able to get the sum. Now one more question you can see. So in this question, again, it looks like so many under root signs, so many things. But again, if you can solve it to write as difference of VR and VR plus 1, it will be easy. Please see. I can write this as summation, and in the denominator, I can take root k into k plus 1 common. Okay, and here, after taking common, we will be having under root of k plus 1 minus under root of k. Okay, and this k is starting from 1 going till n. Here, if we rationalize it, in the numerator it will be k plus 1 plus root k upon root over k into k plus 1. And I think here we will get just 1. After rationalization, this will become 1. So once again, I think we have got, I think I have made one mistake. Yes, here it will be minus. Actually, here it was plus. So here it will be minus and here we will get 1. So you can write this as summation 1 upon root k minus 1 upon root k plus 1. Same thing. This is v of k, this is v of k plus 1. And if you start writing k as 1, 2, 3 up to n, you can now do it yourself. I need not to do it. Let me just tell you the answer. In fact, if you have understanding on this concept, you will see you can write the answer directly, because this 1 will be remaining from the first term. So 1 here minus this n will be remaining, this 1 upon root over n plus 1 will be remaining the last term. So that will be the answer. So I think B should be the answer here. Okay. Now one very interesting question in trigonometry. Please see how this is done. It looks like it is a series in which angles are in GP. There used to be a formula if such thing is given in cos and in cos, and but then if they are multiplied, not they are added, cos theta, cos 2 theta, cos 4 theta, if they are multiplied, there used to be some formula. But here let us see how we can do. So there is very small trick. If you make use of that, I think it will be done. Cosecant theta can be written as 1 upon sine theta. Okay. Now if I multiply by sine theta by 2 here and sine theta by 2 here, I think I have not made any difference. But if we write this sine theta by 2 as theta minus theta by 2, which we can definitely write. Now in the denominator we have sine theta into sine theta by 2. The numerator, if we use sine A minus B formula, will become sine theta cos of theta by 2 minus cos theta into sine theta by 2, and divided by sine theta by 2. So here this cosecant theta, let me write it here, will be, if you write these two terms after splitting, one of them sine theta will get cancelled and we will be left with cot of theta by 2, and in the other one sine theta by 2 will be cancelled and we will be left with only cot theta. Okay, so here you can see if cosecant theta is this, then same way if we write cosecant of 2 theta, it will be cot theta, because theta is changed with 2 theta, so cot theta minus cot of 2 theta here. Similarly, if cosecant of 2 square theta is to be done, it will become cot of 2 theta here minus cot of 2 power 2 theta here, and so on and so on. The nth term, which is cosecant of 2 power n minus 1 theta, is equal to, we can write this as cot of, I think this will be 2 power n minus 2 theta, and here it will be cot of 2 power n minus 1 theta. Okay, you can notice this theta and this theta, they are same angle, and this one is half of these two. So here if it is 2 power n minus 1 theta, this is also 2 power n minus 1 theta, but this one is half of these two angles. Now the summation time. So if we add them, you can check this cot theta gets cancelled with this, cot 2 theta gets cancelled with this, and so on and so on. Here cot theta by 2 is remaining. So here cot of 2 power n minus 1 theta will be remaining. This will also get cancelled. So what we are left with, cot of theta by 2 minus cot of 2 power n minus 1 theta. So this is how we can prove this. There are number of problems based on telescopic sum in trigonometry. If you remember, such questions are there in all the standard books also. So there also we are using same telescopic sum to split the term. There can be different tricks, but more or less you are going to do same thing after splitting them. Now coming to this question, in which tan inverse 1 upon 3 plus tan inverse 1 upon 7 and so on is given. First, those who are in 11th grade, you may not be knowing what is tan inverse. So for them, I will tell you one formula that is required to solve this question, and this formula is tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. and this will be valid if x into y is greater than -1. Okay, so we are going to use this thing, but for that let us understand what is my rth term. Okay, so rth term is tan inverse 1 upon 1 plus r square, and you can see I want this kind of expression x minus y upon 1 plus xy, so that I can write this as a difference of 2, the fundamental thing for telescopic sum. So here we can write this as tan inverse, and we can write this as 1 plus r into r plus 1. Okay, and we want the difference of these two in the numerator. So I think it has become very easy now to see that it will become r plus 1 minus r, that's it. Okay, so you can see it will be now tan inverse r plus 1 minus tan inverse r. You can check that condition also, that product of these two x and y are greater than -1 or not. R and r plus 1 both will be positive, so it has to be greater than -1. Now again same thing as I am telling you, this is VR plus 1, this is VR. So T1 would be tan inverse 2 minus tan inverse 1. T2 would be tan inverse 3 minus tan inverse 2, and so on. And Tn would be tan inverse n plus 1 minus tan inverse n, isn't it? So if I have to add them, so we have been doing so many questions as of now. So Sn would be, I think this tan inverse 2 will get cancelled. Then tan inverse 3 will also get cancelled with the next term. And because tan inverse 1 is remaining, here tan inverse n plus 1 will remain. This will get cancelled with the previous term. So here we will get tan inverse n plus 1 minus tan inverse 1. And that is the answer. As you know, tan inverse 1 is pi by 4. I think this thing can be understood by even 11th grade students, because tan inverse 1 should be that angle which will give the value of tan as 1. So it will be pi by 4 here. So the answer here you can see has to be B. Now next I am going to tell you one very interesting and challenging problem. It is this question is based on binomial coefficient actually. Reciprocal of binomial coefficient rather. Please see how this is done. So to do this question, first let me remind you one property of binomial coefficient. What was that? It was NCR plus NCR plus 1, and this used to be N plus 1 CR plus 1, isn't it? Or if it is N plus 1 CR plus N plus 1 CR plus 1, I think it will be N plus 2 CR plus 1. In the number written below are same, but here in place of N it is N plus 1. Now why I am telling you this? That there is one very interesting property similar to this only when you write these numbers in the reciprocal. So what I am trying to tell you, that if we write 1 upon N plus 1 CR plus 1 upon N plus 1 CR plus 1, let us see what will it become. I can take the LCM, and this will be N plus 1 CR into N plus 1 CR plus 1. And in the numerator, because these two will be added, so it will become N plus 2 CR plus 1. Okay. Now, what we can get from this, please see, I think the numerator can be written as N plus 2 common. Then it will become N plus 1 C. I think I can write this as R only. I think we can write this as R only. But for that, I will have to divide it by R plus 1. Okay. So you can check this N plus 2 C R plus 1 is N plus 2 and R plus 1 are outside. So N plus 1 CR. And in the denominator also, you can check it will become, let me change this one. So we can write this as N plus 1 upon R plus 1. So it will become NCR. And this will be cancelled directly. Please check the calculation. I think this will be cancelled directly, and this r plus 1 is also cancelled. So we are getting this to be n plus 2 upon n plus 1 and 1 upon NCR. I'm going to use this result in the solution. So let me copy this solution. Let me write 1 upon NCR now. So can I write 1 upon NCR equal to, and here we will get n plus 1 in the numerator, n plus 2 into the denominator. And here it is 1 upon, if you remember, n plus 1 CR plus 1 upon n plus 1 CR plus 1. Let us check it once again. So we started with this and we obtained this. So 1 upon NCR can be written as n plus 1 upon n plus 2 into this 1 upon n plus 1 CR plus 1 upon n plus 1 CR plus 1. Now, what is our question? Our question is summation of minus 1 power r upon this thing. So what will be minus 1 raised to the power r upon NCR is equal to, we can write this as n plus 1 upon n plus 2, and here I can write this as minus 1 raised to the power r upon n plus 1 CR plus minus 1 raised to the power r upon n plus 1 CR plus 1. Now tell me, can we write this once again using small modification? Here I am writing same thing, minus 1 raised to the power r upon n plus 1 CR, but here I am introducing minus sign, and for that I am writing the power of minus 1 as r plus 1. So basically we have put actually 2 times minus 1, which is nothing but plus. So nothing will change if we write this way. Okay, so we have got minus 1 raised to the power r upon NCR like this. Okay, now I think we all know how such questions are done. Let me complete it. We have to start it with from r is equal to 0 to n. So the sum, let me write s here, of n terms. It is actually n plus 1 term because it is starting with 0 going till n. So let me not write Sn, let me write only s here. S means sum. So this will be, first we will be writing r is equal to 0. So we get n plus 1 upon n plus 2 outside, and let me write this as outside only because it is same for all the terms. Here we will get minus 1 power 0 because we are writing r as 0 first. So n plus 1 C0 minus 1 raised to the power 1 because we are putting r is equal to 0 here, and n plus 1 C1 here. Let me close these two terms in one bracket. Then putting r is equal to 1 will give us minus 1 raised to the power 1 upon n plus 1 C1. Then minus 1 raised to the power 2 upon n plus 1 C2. And so on and so on. Okay, and the last term would be, let me write the last term. So minus 1 raised to the power n upon n plus 1 Cn minus 1 raised to the power n plus 1 upon n plus 1 Cn plus 1. So as we have been doing, it can be checked that this term gets cancelled with this. This will get cancelled with the next because this first term is left. So here this last will be left. So this sum s here would be n plus 1 upon n plus 2, and first term is nothing but 1 only because minus 1 power 0 is 1, n plus 1 C0 is also 1, and minus, here it will be minus 1 raised to the power n plus 1, and in the denominator it is again 1 only. So this is what our answer should be. So we can write it this way also, n plus 2 and 1 plus minus 1 raised to the power n. Okay, you can check, this will become 0 for n equal to odd. In fact, this can be, this could have been concluded directly from here also. So what will be the answer? I think as we have got plus here, so answer will be A. So A is the answer for this question. One very challenging question, but using VN method or telescopic sum, this becomes super easy, isn't it? Now I'll show you the power of telescopic method in some product also. Please see. Here we are given Pn as some terms multiplied in the numerator, some terms being multiplied in the denominator, and we are asked what can be P100. But before that, let me tell you, if you have this expression k power 4 plus 1 upon 4, okay, this can be factorized. Please think about it. I think we can write this as k square plus 1 upon 2 whole square minus k square. Please check. The whole square of this bracket will be k power 4 plus 1 by 4 plus k square, which was not there, so we have subtracted outside. Okay, so we will get the factors of this as k square plus k plus half, okay, and other one k square minus k plus half. In fact, this is a special case of one very famous identity known as Sophie-Germain identity. Okay, now let me write this once again like this also, k into k plus 1 plus half, one bracket, and in the another bracket k minus 1 here, k here plus half here. And once again, if you notice, I think we have used similar thing in our one of the example, if I'm not wrong. Let me see which example it was. Yeah, I think this one, 1 upon 1 plus r square plus r power 4, similar to that only. So you can see here that this first bracket is kind of v of k plus 1, and the another bracket is v of k, isn't it? You can check the corresponding terms in place of k. Here we are having k minus 1, and same with this term also. Okay, now if we have to find P100, so let me write the values of this Pn using this factorization which we have just done. Okay, so how it will be done? Let me copy this question there. Okay, so we did the factorization of this k power 4 plus 1 upon 4 as this. Let me write it here. K power 4 plus 1 by 4 we wrote as k into k plus 1 plus half as one bracket, multiplication with k into k minus 1 into k plus half in the second bracket. Let us check. Yeah. So what will this Pn be? Let us see. Let us write first the numerator terms. Let me try to write all the terms. What all the terms means? Maximum possible terms. So first one would be, if you take k is equal to 1, it will be 1 into 2 plus half into, then k minus 1 will be 0 into 1 plus half. The next bracket, k is equal to 3 we will take, so it will be 3 into 4 plus half. Then it will be 2 into 3 plus half. One more term, let us write 5 into 6 plus half, and 4 into 5 plus half, and so on. The factor of this last bracket would be, we will put 2n minus 1 in place of k, so it will be 2n minus 1 into 2n plus half, and the other bracket will be 2n minus 2 into 2n minus 1 plus half. Okay, I think this is how the factors of numerator terms would be. In the denominator, if you write, it will be 2 into 3 plus half, and here it will be 1 into 2 plus half, 4 into 5 plus half, 2 into 3, not 2 into 3, it will be 3 into 4, 3 into 4 plus half. For next one, it will be 6 into 7 plus half, and then 5 into 6 plus half, and so on. The last bracket will be 2n into 2n plus 1 plus half, and here it will be 2n minus 1 into 2n plus half. And let us see what all are getting cancelled and what are not. So this 1 into 2 plus half is getting cancelled with this. This 2 into 3 plus half is getting cancelled with this. This 3 into 4 plus half is getting cancelled with this. This 4 into 5 plus half is getting cancelled with this. This 5 into 6 plus half is getting cancelled with this. So far you would have noticed that this is not going to cancel anywhere. But other than that, all brackets are getting cancelled. You can check. This will also get cancelled with the next term. So in the numerator, the only bracket that will remain is, I think, 1 by 2. Whereas in the denominator, what will be remaining? I think this will remain because there is no such bracket in the numerator. Other than that, I think this is also getting cancelled with this. So we will be having 2n into 2n plus 1 plus 1 by 2. Multiplying by half, multiplying by 2 in numerator and denominator, we will get 1 upon 4n into 2n plus 1 plus 1. And we are asked p 100. So let us write n as 100. So 400 into 201 plus 1. So that is the answer. You can write the number after multiplication also. So I hope you have understood the power of telescopic method in the products also. So many questions are done this way also. So coming to the teaser question of the day, okay. But before that, let me tell you, we have been, presenting you all these videos every Sunday. Although KVPI is not there, but still these videos will serve the purpose for some other exams as well. Now, if you are targeting JEE Advanced, then Vedantu Eklavya is one very big thing for you in online domain. So please know it. If you do not know, please Google it, you'll come to know. Okay. I am sharing with you the link of topper pod notice board, in which you will come to know what all batches are going on and what all new things are coming up in these batches. So please follow this notice board by clicking on this link or by scanning this QR code. Okay, it will be useful for you. If you are going to write JEE Advanced this year in August, you are going to write JEE Advanced in 2022, then this is the link of a group of channel of Telegram, and this is a scan for the same. Just scan it or click on it. You will be made part of Telegram channel, where we are putting all important information regarding Eklavya batches. Okay. Similarly, for 2023 students, for 2024 students, these are the links and QR codes for respective Telegram batches, Telegram channels. We have created V Impact YouTube channel, where you will find JEE Advanced and KVPI solutions question wise, and we are increasing the number of solutions in that channel. So please watch it. These solutions will be worth watching. Please go through it. You will find alternate methods, multiple methods for these questions. So this is the teaser question. I have made this question based on that property I told you in the class itself, and I have mentioned it here: tan inverse x minus tan inverse y equal to tan inverse x minus y upon 1 plus xy. Okay, so you are given a series in which you are given tan inverse 5 upon 25 plus tan inverse 7 upon 121 plus tan inverse 9 upon 361 plus tan inverse 11 upon 841, and so on. You can see the pattern. So you have to find what will be theta n and what will be theta n when n will approach to infinite. So that is a teaser question of the day. And if you have solved this, do not forget to send your solution to this email ID, eklavyaSupport@vedantu.com, with subject line teaser solution maths. If we like your solution, we will call you, we will have interaction with you, and we will make you part one of our ongoing programs or new programs. Okay, so thank you so much. That is all for today. Bye everyone.